Hello, so this was my other idea for how we can do presentations. So once I'm done, I will export this to YouTube and we can then talk about it in our Zoom meeting next class. In case I'm not here, I might be there tomorrow. I'm not sure at this point, guys. So start by doing a quick highlight of what I'm planning on covering this session. So I'm going to talk about the stereotypical steroidal structure. I'm also going to talk about lipid-soluble vitamins because a really important class of those is steroid-derived. And I'm also going to talk a bit about steroid hormones. I'm then going to talk about HDL and LDL cholesterol and the use and abuse of steroids. So I'm really only talking about steroids today and going to tick off those really 3 steroid points. Okay. Okay, so overall what we've got here is our characteristic 4-ring structure that is known as a steroid backbone. It's also a 4-ring fused structure. Okay, so cholesterol over on the right, you have this image in your data book. This is a slightly different presentation, but let's look at what parts of this are polar and non-polar. So obviously, this entire portion of the molecule is non-polar. And this little bit, and I'm just going to switch to blue, this tiny little corner down there is polar. So what does overall polar versus non-polar, what does that mean for this thing's solubility? Basically, because it is effectively a non-polar molecule. Yes, there is a polar end, but it is a non-polar molecule overall. The solubility is quite good in fats. And poor in water. So this is why if you put, like when you're doing the dishes, you need to be adding soap. Now, biology people, you might talk about surfactants and things like that. We don't talk about them in chemistry at the IB. But basically, cholesterol and cholesterol derivatives are not water soluble, which is why if you're taking a vitamin D pill, for example, it's an actual capsule. It isn't like a dissolvable tablet that you can take like with vitamin C. Okay, let's move on. So this is a sort of flow chart for some of our main steroid hormones. So we go from cholesterol up in the top left corner and we see these flow charts. Now, one thing that's important, and it's going to come back later when we talk about steroids as drugs, a lot of these things are equilibria. Remember, in biology, one of our key concepts is homeostasis. So, for example, so all of us have these pathways in our bodies, and we, to a certain extent, so estrogens and androgens. Androgens include things like testosterone. So andro, in terms of the Greek name, means man. So an androgen is something that makes a man. So this is on a chemical level. So we're looking at testosterone and other chemicals like that that are the hormone signalers for male. And I'm using male as a biological category, not as a gender category. There's a whole bunch of complications when we start talking about gender. I'm just talking about the chemical realities of hormones at this point. Cortisol is a super important hormone in animals. It's sometimes known as the stress hormone. So cortisol levels are what is used a lot of the time to measure stress levels. If you're studying psych, you might have talked about cortisol as a stress chemical. So estrogens and progesterones really, those are the female quote unquote hormones, and they're in the oral contraceptive pills. So corticosteroids, and again, going to talk about it later, they can be used as medicines as well. Okay, let's continue on. So, sorry, before we move on, the important point to take from this is steroids are absolutely part of our chemical makeup, and all of these things are about homeostasis, so about that balance. Okay, let's continue. So this is one of the more famous this is a steroid derivative vitamin. So vitamin D is basically what happens when I start with a four-membered ring structure and I break apart this B ring. So you can see here, if I go back to my pen, I have, what colour pen am I on? That doesn't help me. So I've got my A, C, and D rings. So this one is directly from your data book. So if I take a steroid skeleton and I break open that B ring, I end up with the core of a vitamin D molecule. So vitamin D is really important and it helps. So the other name for vitamin D is cholecalciferol. So chole from the cholesterol and calci because it's involved in calcium management in the body. I'm not going to go into too much detail, but vitamin D, and that might even be D3, I can't remember. Its name reflects what it comes from and what it does in the body. So vitamin D is formed, as you probably know, from sunlight. So basically what happens is in some of the cholesterol that we intake from our food, on exposure to sunlight, and we've gone through all the organic chemistry reasons why sunlight can be important, it breaks open that B ring of the steroid skeleton, and then we end up with this super important signaling molecule. Now, so we all need a certain amount of sunlight exposure every day to keep up our vitamin D levels. It's actually one of the really interesting things that's happened as a result of the Slip Slop Slap campaign. It has massively increased the number of people in our society that have low vitamin D levels. So a lot of people are now on vitamin D capsules or tablets. That is basically because people aren't getting enough sunlight. It's that balance between getting enough sunlight so we keep our vitamin D up, but not so much that we then cause DNA damage, which leads to skin cancer. So that's vitamin D. Let's continue. Okay, so what we've got here is an image in French, as it turns out, of high density lipoproteins and low density. So basically, yes, we all need cholesterol to live and we all need triglycerides to live, but because of modern eating trends and things like that, we are seeing a shift away from having high density lipoproteins to low density. Low density is usually called bad cholesterol, and low density is normally called, and I'm going to put those in inverted commas because a chemical can't have an ethical framework. Okay, so what makes our low density lipoproteins quote unquote bad? If I've got an artery, what can happen with my LDLs is they can form plaques or plaques on the sides of my arteries and constrict blood flow. Now, that can lead in extreme circumstances to strokes and heart attacks. So this is called a plaque, like the crusty stuff that Oral-B commercials always warn you about. And basically it gums up the arteries and it blocks blood flow. Okay, so this medical process of this plaque formation is called atherosclerosis. I'm not even going to try and spell that, guys. Yes, so let's continue on. So there are a bunch of medical uses for steroids. I've spoken about some of them already. So steroids come in the three main classes. So one class is used a lot for people who have kidney trouble. So I don't know if the bio people have talked about water regulation cycles, so vasopressin and I've forgotten the other hormone that's involved. So people who have certain kidney troubles might need to go on a form of steroid. Glucocorticosteroids, I'm actually on one of them. It's in a skin cream I use to deal with my dermatitis. So glucocorticosteroids are anti-inflammatory. And they're also immunosuppressants. So if somebody is having a transfusion, not a transfusion, a transplant or something like that, they might be on a form of immunosuppression. So basically my skin, I get dermatitis because my immune system overreacts to an ingredient in soap, which is great at this time in this time where I'm washing my hands every 5 seconds. So basically by putting this cream on my skin, I'm telling my immune system to calm the hell down. Anabolic steroids are usually the ones given a bad rap, but if you've got particularly a child that has delayed puberty or some sort of issue with their sex hormones, we can give them these drugs in order to basically kickstart puberty. Okay, so those are the medical uses of steroids. They are absolutely legitimately used all the time in medicine, but basically the only type that gets any press is the illegal users of steroids. Now, most of the time when people are using steroids illegally, it is these anabolic androgenic steroids. So anabolic, if you remember our reaction type, is building up. So remember how I also said that this sort of flow chart was going to come back? So think about it in terms of equilibria. If I suddenly increase my concentration of androgens, I'm going to see increases in my amount of estrogens. Now, what that means is I'm going to end up with a bunch, and this is one of the most common side effects of people on steroids, anabolic steroids, males. They actually have shriveled testicles and they can develop, for want of a better term, man boobs. The estrogen levels in their bodies increase to the point that they actually develop some feminized structures. So steroids can be found using a blood test. One question I want you to write down and think about: why can't steroids be found with a urine test? So why can't I find steroids using a urine test? Can you please write down that question and we'll discuss it in our Zoom session next time. Okay, so in this presentation, I have spoken about a fused ring structure known as a steroidal backbone. I've talked about lipid-soluble vitamins and hormones, and I've talked about HDL and LDL. Fantastic. Thank you so much, guys. I lied. This is a 17-minute video, not a 15-minute video. Have a fantastic rest of your day.